Hello and welcome to the science class. My name is Teacher John. Today we are going to learn Science Primary 7, Term 3. Today I'm going to learn about reflection of light. In our previous lesson we looked at eclipse and types of eclipse. We drew some diagrams to show solar eclipse and lunar eclipse. Today we are going to learn about reflection of light. The question is, what is reflection? Reflection is the bouncing of light rays. Reflection is the bouncing of light rays. So when light rays bounce off a shiny surface, we say the light has been reflected. So there's a diagram to show reflection of light. We have two rays here. This one is called incident ray. Incident ray. Then this one is called reflected ray. Reflected ray. Why do we call this one incident ray? It's the ray that is striking the mirror or the reflecting surface. Then the ray that is bouncing off the mirror is called reflected ray. The angle between then this line which is perpendicular is known as the normal. This one is not a ray. It's just a line that divides the mirror at an angle of 90 degrees. So it's called the normal. So the angle between the normal and the incident ray is called the angle of incidence. Then the angle between the normal and the reflected ray is called the angle of reflection. So this angle I is the angle of incidence. Angle R Angle R is the angle of reflection. Then, this one is called a plane mirror. Plane mirror. Plane mirror. Then this point is called the point of incidence. The point of incidence. The point of incidence is the point where the incident ray, the normal, and the reflected ray meet. That point is called the point of incidence. So here is something you need to note. NB. 1. The ray that hits the mirror, the ray that hits the reflecting surface, is called the incident ray. The incident ray. The ray that hits the reflecting surface, which is the mirror, is called the incident ray. Then number 2, the ray that bounces off the reflecting surface is called the reflected ray. the ray that bounces off, the ray that bounces off the reflecting surface is called, the ray that bounces off the reflecting surface is called the reflected ray. It's called the reflected ray. Then number 3, the normal is perpendicular between the incident ray and the reflected ray. The normal is perpendicular. The normal is perpendicular. The normal is perpendicular between the incident ray and the reflected ray. When we say that the normal is perpendicular between the incident ray and the reflected ray, what do we mean? We simply mean that normal forms an angle of 45 degrees. It forms an angle of 45 degrees. That's why we are saying it is perpendicular. It forms an angle of 45 of 90 degrees. It forms an angle of 90 degrees. It forms an angle of 90 degrees. That's why we are saying it is perpendicular. So you find that between the reflecting surface and the normal, it is 90 degrees. Between the reflecting surface and the normal, there is an angle of 90 degrees. Then number 4, the angle between the normal, the angle between the normal and the incident ray is called the angle of incidence. The angle of incidence is called the angle of incidence. The angle between the normal and the incident ray is called the angle of incidence. Then the angle between the normal, and the reflected ray and the reflected ray is called the angle of reflection. The angle of reflection. The angle of reflection. The angle between the normal and the reflected ray is called the angle of reflection. That's what we mean by the angle of reflection. It is the angle between the normal and the reflected ray. It's called the angle of reflection. Then the angle of incidence is between the normal and the incident ray. Then the normal is perpendicular. That's all you need to know about reflection. Then next we look at types of reflection. 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 We have regular reflection, regular reflection. Then we have irregular reflection, irregular reflection. These are the two types of reflection: regular reflection and irregular reflection. Regular reflection and irregular reflection. Now let's begin by looking at regular reflection. We look at regular reflection. Regular reflection. Now, regular reflection occurs on a smooth, shiny surface. It 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 occurs on a smooth, shiny surface. And the reflections are regular. The reflections are regular. For example, we are going to draw a diagram to show regular reflection. So we draw the arrows. These reflections are regular. So this type of reflection is called regular reflection. It's called regular reflection. And we said regular reflection occurs on a smooth, shiny surface. It occurs on a smooth, shiny surface. It occurs on a smooth, shiny surface. So that's what we call regular reflection. So this one is a smooth, shiny surface. A smooth, shiny surface. A smooth, shiny surface. So this surface is smooth and shiny. So smooth, shiny surfaces produce regular reflections like mirrors. So, NB. Smooth, shiny surfaces like plain mirrors. Produce regular reflection. Smooth, shiny surfaces like plain mirrors produce regular reflections. I've given you an example of a smooth, shiny surface like a plain mirror. They produce regular reflections. It's as simple as that. So let's look at irregular reflection. Irregular reflections. Irregular reflections. Irregular reflections occur on a rough, shiny surface. They occur on rough, shiny surfaces. Irregular reflection. It occurs on a rough, shiny surface. It occurs on a rough, shiny surface, and the reflections are irregular. The reflections are irregular. The reflections are irregular. So we're going to do a diagram to show irregular reflections. This one is rough, shiny surface. The rough, shiny surface will produce irregular reflections. For example, shall have a ray of light shall have that. Then we have that. So this one shows irregular reflections. We say irregular reflections, they produce smooth, shiny, rough, shiny surfaces produce irregular reflections. And B, rough, shiny surfaces produce irregular reflections. E.g., ion sheets. Ion sheets produce irregular reflections. Reason? They have a rough, shiny surface. They have a rough, shiny surface. Then we look at laws of reflection. The laws of reflection. So reflections have laws. The laws of reflections. The laws of reflections. The laws of reflection. We have around 4 laws of reflection. 1, the incident ray, the normal, and the reflected ray all lie on the same plane. The incident ray, comma, the normal, and the reflected ray. All lie on the same plane. All lie on the same plane. Now, this is what we mean. Let me just draw a simple diagram here and you see. So we are saying this is the plane mirror, this one here. So we are saying the incident ray, the normal, and the reflected ray, all of them lie on the same plane. All these, the incident ray, the normal, and the reflected ray, lie on the same plane. That is a law of reflection. Another law, the angle of incidence is equal to the angle of reflection. These two angles are the same. The angle of incidence is equal to the angle of reflection. So the two angles are equal, and that is the law of reflection. Number 2, the angle of incidence is equal to the angle of incidence is equal to the angle of reflection. The angle of incidence is equal to the angle of reflection. Another one, a ray traveling along the normal is reflected back. A ray traveling along the normal is reflected back along itself. A ray traveling along the normal is reflected back along itself. For example, I can have this. A ray traveling along the normal is reflected back along itself. A ray traveling along the normal is reflected back along itself. Now, you have something like this. This is what we mean by a ray of light traveling along the normal is reflected back along itself. So this is a smooth, shiny surface or plane mirror. This is a plane mirror. That's a plane mirror. So a ray traveling along the normal is reflected back along itself. Is reflected back along itself. Then an object appears a certain color because it reflects that color and absorbs other colors. An object appears a certain color. Number 5. An object appears a certain color because it reflects that color. It reflects that color. And absorbs other colors. So an object appears a certain color because it reflects that color and absorbs other colors. So these are what you call laws of reflection. These are laws of reflection. The incident ray, the normal, and the reflected ray all lie on the same plane. The angle of incidence is equal to the angle of reflection. A ray traveling along the normal is reflected back along itself. An object appears a certain color because it reflects that color and absorbs other colors. So, in other words, red appears red because it reflects red and absorbs other colors. Green appears green because it reflects green and absorbs other colors. That's what that statement simply means. On page 8, there is an activity, page 8 and 9. Please attempt that activity following what we have learned today. Let's look at reflection and light. Reflection and light. That should be our heading. Reflection and light. So here we shall say brightly colored objects. Brightly colored objects reflect. Brightly colored objects reflect more light. Reflect more light. And heat. Then, number 2, dull colored objects. Dull colored objects. Dull colored objects absorb more light and heat. Absorb more light and heat. So we are simply saying that objects which have bright colors will reflect more light and heat. Then objects which have dull colors will absorb more light and heat. That's why here you can say white or bright colored objects reflect heat and light. Then here, black or dull colored objects absorb heat and light. Now, that's what you need to know. That black or dull objects absorb heat and light. Then an object which is white or brightly colored, it will reflect heat and light. That's why you may find questions like, why do white shirts take long to dry? Because they reflect heat. Let's write some questions here. Why do white shirts or skirts take long to dry after washing them? Why do they take long to dry? It's because white reflects heat and light. White reflects heat and light. That's why a white shirt will take long to dry, because most of the heat is reflected. Another question. Why do black shirts dry faster after washing? Question number 2. Why do black shirts dry faster than, why do black shirts dry faster? It's because black absorb more heat and light. Black absorbs more heat and light. That's the reason why a black shirt will dry faster, because it absorbs more heat and light. Another question. Why do black shirts dry faster than white shirts after washing them? Why do black shirts dry faster than white shirts after washing them? The answer is simple. Black absorbs more heat, while white reflects more heat. So that means that if you wash the black shirt and the white shirt at the same time and you try to dry them, the one which is black will absorb more heat and it will dry faster. Then the one which is white will reflect more heat and it will take long to dry. It is as simple as that. So that one brings us to the end of our lesson. Please attempt the activity which is on page 9 and page 10. attempt that activity. May the Almighty God bless you and stay safe.